Alright, so in the last video we basically wrapped up all the finishing touches on this typical wall section. So in this video we're going to go through and annotate it. Basically add notes calling out everything that's on the drawing. So we'll just start at the bottom and work our way through. So the first thing to notice is that our scale is at 1 inch equals a foot. So I'm going to switch to my Annotate tab. I'm going to choose multi-leader, and before I do that, actually I'm going to put A-text as the current layer. Scroll in here and I'm going to start adding text. And go back to Annotate, multi-leader. So the concrete footing, basically what we want to do is we want to have this as a 2500 PSI concrete footing. Okay, so that basically just indicates the strength of the concrete. And actually we're going to add some to it. I'm going to call out the size here as well. So 8-inch thick by 24-inch wide, 2500 PSI concrete footing. So I'm going to take this up here, and leave the note like that. Alright, the next thing, this former drain. It is going to be, now this comes in different heights to accommodate different height footings. This is going to be our 8-inch former drain. The pipe coming out of our former drain is going to be a 4-inch, and we're going to go ahead and say schedule 40. And schedule 40 is basically a thicker walled pipe. Instead of using a sewer and drain pipe, which has pretty thin walls, we're going to use a thicker wall pipe to connect onto this. It's also a rigid pipe instead of a corrugated pipe that's flexible. And we're going to say 4-inch schedule 40 drain to daylight, which basically means that we're going to take this out and run it in a trench somewhere until it hits, it opens up to the open ground where it can drain outside. That's what to daylight means. Alright, the next thing, we're just going to call this out as finished grade, slope away from building. The next one is going to be our backfill, and we're going to use 2B, which is the size of the stone, 2B crushed limestone backfill. And the reason that we want to use crushed limestone, the reason that we specify crushed limestone, is it's not going to disintegrate like a sandstone would. So it's not going to break down, it's not going to compact, and it gives you a better overall performance. It is more expensive than using a sandstone. A lot of people will use shale to backfill with. The best situation is to use a crushed limestone, size 2B. So we can come in here and point at our, and what we're going to do with this, we're going to do a little bit differently than what we had shown. We're going to add our multi-leader, and I'm going to turn my ortho on. I'm going to come straight up, and I'm going to basically call out the entire assembly here instead of having 3 or 4 different nodes. So we have a 4-inch thick 3,500 PSI concrete slab on 2-inch thick R10, that's the R value associated with the styrofoam, on, and then the next thing, we would have a vapor barrier to keep any moisture from coming up through, and that vapor barrier is going to be 6 mil thick. I'll spell out 6 mil thick vapor barrier on 2B crushed limestone. And there I have one note that covers everything. So I'm going to go ahead and stretch this up. And what I'm going to also do is I'm going to go ahead and I'm going to explode this. And then I'm going to mirror this leader down to here. And it's basically going to show the whole way through this assembly. And then I'm just going to drag this up a little bit. So one downside is your leader down here is over top of this gravel. And the thing you have to remember is this gravel is a line 241 thickness. The color is 241, it's 0.002. And this is going to be 0.1 or 0.01 for thickness. So it's quite a bit thicker, so we're going to hope that this leader shows through whenever I look at this. Alright, on this side, we're going to kind of point to this area right here. And we're going to call this out as 8-inch form a drain with 4-inch radon vent through roof. Okay? All right, the next thing is all of this stuff. So I'm going to have to extend these all the way out past here to actually see this. So I'm going to try to do the same thing where I have basically an assembly that goes the whole way through this. So I'm going to point there and I'm going to say eighth-inch thick cement carge, which is basically just a cement that gets applied to the surface of the CMUs on 8-inch, zoom so I can see my note, on 8-inch CMU foundation with 2-inch R10 styrofoam and that's pretty much all I would need to have. And I'm going to backspace, enter, spread that note out a little bit, and then I might stretch this note in a little bit. And that covers that entire assembly. I already called out the stone here, the stone there. Alright, so moving on, I think I got everything down in this area. I don't have this cove. Seems like it should be obvious, but we're going to call it out anyways. And we're going to call this create cove with parge, basically just to shed that water away from the foundation. Alright, moving on up here, we can do this entire wall assembly at once in the same way that we did the other ones. So I'll just start here, and we're going to go from the outside in and say vinyl Dutch lap siding on Tyvek building wrap. So that's going to be basically a vapor barrier that's going to allow air to permeate through and water vapor to not get passed through. So you could have water vapor within the building that can get out, but water droplets cannot get in. And it's also going to help with air infiltration. Tyvek building wrap on half-inch. We're going to call this out, instead of half-inch, we're going to say 7/16 OSB on 2x4 stud at 16 inches on center. That would be the spacing of the studs, with R21, that's the value of the insulation in the cavity, R21 rock wool insulation, bats, and I think we have to take the bats to the next line. With half-inch sheathing, finished sheathing on interior. Because I don't know whether I want drywall or what kind of finish I want on the inside of that garage. So again, I'm going to explode this, and I'm going to mirror this to the other side. And again, turn my ortho or my O snap off, and then just move it back into place. Alright, so that covers that entire wall assembly. Up here, we start out with all this stuff out here. So I'm going to point to this one, And I'm just going to call this out as 2x4 fascia board. I'm going to call this out as aluminum fascia finish. Call this out as drip edge. We'll call it aluminum as well. Aluminum drip edge. We'll do the vented soffit now. Vented soffit. And I'm actually going to move this one point here and call this out as vinyl F channel. One more thing back here. So this is going to be my sole plate, and this is basically how the walls are connected to the slab. I need to point at this, and I'm going to call this pressure treated. And anytime you have wood that's in contact with, directly in contact with the concrete, you're going to have pressure treated. Pressure treated 2x4 sole plate on sill seal. So the sill seal is basically going to be we'll do two layers. Two layers of sill seal, which is basically a 3.5 inch wide strip of foam, roll of foam that I roll out, put underneath this, and it's going to help seal the gaps so that air infiltration doesn't come in. On 2 layers sill seal, and we're going to attach with 1/2 inch anchor bolts. So there'll be anchor bolts embedded into the concrete at every 48 inches. Okay, so the next one is to call out this double top plate, and it is simply just a double top plate. 2x4 double top plate. I'm going to stretch this down a little bit so I can get something in here. And I'm going to do a note that goes the whole way across this. So I'm going to draw this perpendicular to that. And I'm going to have fiberglass / asphalt shingles on synthetic felt, which is basically going to keep the shingles from sticking directly to the OSB, and it's going to give another layer of protection, especially during construction before the shingles can get applied. So we have fiberglass / asphalt shingles on synthetic felt on 5/8 thick, 5/8 inch thick OSB on prefab. So this is a truss that's going to be prefabricated in a factory somewhere. Prefab truss by others. With 12-inch thick R38, the R value, cellulose insulation. And one more with 1/2 inch finish sheathing on bottom cord of truss. So I need to stretch all this up. And I'm going to take it up one more because I need to add another note in here. And then I'm just going to simply call out or add this to the mix. So I'm going to explode this. And I'm going to mirror it. Just get it close. I'm going to bring it down here. Actually, I think what I'm going to do is just copy this one, bring it up here, and have it look like that. All right, the last thing is we also want to have a vent baffle in here. And basically, it's just a baffle that goes between or in the cavity of the trusses, so in between the top cord of the trusses, that provides a continuous airflow 1 inch thick the whole way through here. So if we would push this insulation out into this, it doesn't break off that air movement. I don't really need to draw that in here. I'm just going to point to this area and call it out. So I'll just copy this piece of text here, point there, stretch this up a little bit, and modify this. Vent baffle. Tip. And I can pull these a little bit closer, stretch this down, and basically everything is annotated there. So at this point I would just go through and maybe do a little bit of cleanup work, pull things in a little bit tighter, make sure that everything's going to fit on the drawings. Hanging out there quite a bit. This could be moved in some. Got my arrowhead. Okay, then the next step would be to go over to layout 1, and I'm going to basically go inside of my viewport and adjust this a little bit so I can get everything inside. It doesn't look like I'm going to be able to get everything to fit, and it is at the 1 inch equals a foot scale. So I have a little bit of room to work with right here to bring this down. Still can't get everything to fit, so at this point I would need to go back in and try to make some changes and get all these things to fit within here. The other thing that I could do, and you see this a lot of times, before I do that, I'm just going to add one dimension here. I want to dimension from this slab up to the ceiling. I don't think I have that shown anywhere else. So at this point I could go through, and I actually want this to come out here to this end point so that I have that gap showing. So I'm going to go ahead and explode this because I'm going to need to break this wall in half. So I'm just going to grab these, pull them down a little bit closer to that, and at this point I could go through and put in a break line here because I don't need to show all of this wall. So the break line is basically going to be, we'll just make one from scratch real quickly. So that could be a break line, and if I really wanted to, I could clean it up a little bit just by adding a little bit of a fillet in here. That's a 1/2 inch fillet, and I'm basically going to take this and I'm going to move it to here, and I'm going to have the next one up here, and then I'm going to trim all this stuff out. So right now I'm choosing those objects as my trim lines. The only thing I foresee having problems with is this one. So at this point I can go through and trim all these things out. And then I would need to erase these. And I would just need to bring this back a little bit, kind of fudge it right there, and do the same thing on the top. And then I could stretch the whole thing down closer. So these break lines basically indicate that, hey, this wall is actually longer than what is shown here, but I'm going to break it so that I can fit everything in the drawing, and if you want an accurate representation of the actual height, then look at this dimension. And that's why I needed to explode this dimension. So to go back to my layout 1 and see if this fits, I can basically scoot everything up at this point, and now everything fits within this viewport. The only other thing would be to add a drawing title down here.